Okay, welcome to our panel discussion. So now's your chance to hear from some experts about some real-world IP solutions, and also to have a chance to participate and ask some questions if you're interested. So I'm going to hand it over to Matthew Goldman from MediaKind, and he's going to be leading the discussion today, and we will let him introduce all the other panelists.
So thank you very much for coming. In the panel session here, we're going to talk about all IP success stories, basically real-world implementations. And before we get going here, I just want to have everybody introduce themselves. I'm Matthew Goldman. I'm the Senior Vice President of Technology from MediaKind. If you haven't heard who MediaKind is, it is Ericsson Media Solutions. We spun off from Ericsson 2 months ago. And it's all the media business from Ericsson. And with that, we'll just go right down the line, your name and what you do there.
Hi, I'm Dan Murphy. I'm from NEP Australia. So I'm from the Andrews Hub project. So we've got a 2110 facility, remote production, that basically spans the same length of the distance of Europe. It's 3,800 kilometers to our longest venue. We've got 9 IP/hybrid trucks on the road, 2 production facilities in Sydney and Melbourne, 7 control rooms. We're doing around about 500 projects a year, remote production out of that. And I'm one of the broadcast engineers working inside the facility on the tools.
Great.
I'm Mike Wilken from Fox Sports. I lead the systems and technology team across the Fox Sports facilities. That's Los Angeles and Charlotte, North Carolina. The IP work that we've done in LA is recently we just put in, the 2110 router. Still in the process of cutting over the last phases, but we've been working on it for a little bit more than a year. One of the first facilities to go 2110, and it's been fun.
Hello, I'm Francois Legrand, Senior Director of Core System Engineering for CBC Radio-Canada. CBC Radio-Canada is Canada's national public broadcaster. We are building a new facility for our French services out of Montreal. So the new facility is being built as we speak. We are doing the technical system integration as we speak. It's going to be a fully 2110 compliant facility. Scheduled to be finished by the end of 2019, and early 2020 we'll start to move the production from the old building into the new building. So I like the title, so it's going to be a future success story. We're not at the success story stage yet, but it's going to work fine. I'm very positive.
Right, so great on that. So I guess I think it's worth a few moments, if you haven't been in a previous session here, to differentiate it a little bit, because the venerable interface for the carriage of media, whether it's audio, video, or data or metadata, has always been in the uncompressed world. There's been SDI, as you know, the serial digital interface from the Society of Motion Pictures and Television Engineers. And since then, the migration has gone to 2 later versions of that, also from SMPTE, and one of them is SDI over IP, which is SMPTE Standard 2022-6. But what we're talking about here is the carriage of real-time professional media over all IP. There is no SDI framing level in that, and that's SMPTE Standard 2110, with the timing being provided by SMPTE Standard 2059, which is a broadcast profile for IEEE 1588 Precision Time Protocol, a PTP. Lots of words, lots of lettering on there, but it's just to set the stage of what we're talking about here, because we truly are talking about real-time professional media, high quality of service, big service level agreements, 24/7/365, no retransmission. This isn't regular internet protocol where you get a drop packet, you then do a retransmit. No, if it gets dropped, you've lost the packet. So we have to do it by other mechanisms for doing that. And it has no SDI layer in there, which again, the advantage of this is then you can use all the IP infrastructure to be able to access the individual streams, as opposed to having specialized broadcast industry specific embedders and de-embedders and things like that. So with that set in the stage by that, we've mentioned a few here. So there's the baseline standards for the transport of professional media, which is SMPTE Standard 2110, along with the Precision Time Protocol, which is SMPTE Standard 2059. And we also have the Advanced Media Workflow Association specifications. Actually, they're Network Media Open specifications, and several of those will be implemented as part of an end-to-end solution for doing this. So with that in mind, again, going down the line, obviously NEP was one of the first in the world to do a complete 2110-based solution for that. So have you implemented anything in addition to 2110? Okay, so take a few moments to explain your hubs and how they kind of work. That'd be great.
Yeah, so we have, for Fox Sports in Australia, we set up 2 hubs, one in Sydney, one in Melbourne, and we provide everything from Tier 1 sport, football, A-tier football, AFL, soccer, rugby, out of those 2 hubs, and we've been running for about, 14 months in the real hubs that were purpose-built, greenfield facility. And before that, we had a few months of testing in our interim hub that we built for R&D. And that is 2110, uncompressed video, up to 34 cameras across Australia. And as I said, the maximum distance that we go at the moment is 3,800 kilometres. That's all in real time, low latency, so we have commentators on the field with IFBs, we have cameramen on the field filming it, we have an IP truck or a hybrid truck at the facility where our CCU operators and techs are working. But all other production is back at the hub. So replay, the director, the DA, producers, graphics.
So then all the graphic insertion done remotely, what we call at-home production.
Yeah. So we use a whole bunch of things to make that happen. Obviously, there's the base standards you're talking about, but MMOS is rapidly becoming part of our workflow to make the establishment of flows and the interoperability between different devices that have to subscribe to those flows work more seamlessly. So with ISO 4 and more we're seeing ISO 5 come into our devices. So we're using a range of devices. The core stuff for us is Arista switches doing the routing, and we've got a combination of Sony and Lavo and Ross and Embryonics providing a whole bunch of solutions for all of that, as well as Viz and a lot of the other sort of device-based parts of our workflow.
Great. So just for those that don't know what ISO 4 is, so that is the AMWA specification. It's for discovery and registration and identity, and then you also mentioned IS-05, which is connection management. So with that in mind, let's continue right down on. So what does Fox Sports have either implemented now or to be in the near future that's all based on all IP?
Well, we implemented the Evertz EXE router, and we're about 3/4 of the way through cutting the Fox Sports facility in Los Angeles over to that router. It's all through the Evertz IP gateways. We don't do any native 2110 at this point. It was more of a replace an aging routers and put it under one, routing platform and one routing control system. It solved a lot of issues just by doing that. We also, in the process, are replacing all of our multi-viewers with IP multi-viewers. And that really made one of the biggest impacts was having that seamless integration with the multi-viewers and the router itself.
Fantastic. And Francois, for CRC, your plan, of course, is to go with completely all IP to begin with, not SDI over IP, right?
Yes, our plan is to use IP native endpoint as much as possible. I'm really happy to be after you two guys because the market evolved fast, and stuff that was not available as pure IP 2 years ago or 1 year ago, now it is. And people that will be 1 year after me, I will very like to be at your place, so that's good. Our objective is to use as much as possible IP native, as I said, but the thing is that some device, either they don't exist with native IP, or they're not reliable yet. So that's why very early in the process, we made the decision to have a known broadcast controller that we know and trust on top of a very reliable network, and to partner with a gateway company, which is Embryonics in our case. That's always our plan B. So whenever there's an issue with a device because either the IP is not reliable or we cannot control it for whatever reason, so then we use gateway. Next year, I will be able to tell you what's the percentage of IP native versus SDI device. It's going to be way more than half that will be IP native, but would it be 30, 40%? I don't know at this point.
So with regards to implementation, I mean, we're hearing about this, and the different standards and specifications, of course, have different levels of maturity based on the equipment out there. It wasn't long ago where you could actually buy a monitor with a native IP interface on it. Again, this isn't like an IP interface that you have on a standard consumer television, which is just the internet connected to it. This is one that supports the professional media over IP protocols on that. And it is kind of strange to think about that because we're so used to putting either HDMI or SDI directly in the display, and here the only connection might be a 100 base T connection or something like that when they think on that. But when you start to look at these things differently, putting these large systems together, what was the biggest surprise you had when you were putting it together about things that maybe you would have wanted to do differently, or your biggest surprise of things that worked really well?
That's a big question. I think there's been a lot of challenges along the way. I mean, we got in when the standard was really only just being ratified. And
we were one of the earliest ones.
We were on air.
Brave souls.
Yeah, we were on air before some of the standards that we now rely on were even published, or completely ratified. So, there's been a lot of growing pains with that. I think, for us, one of the things that's been something we've been hanging out for is really MMOS and seeing more of the connectivity.
For the control side of it.
For the control side. I mean, the technology itself works. It's, and when implemented and when it's, in a product that is reliable and streaming, then, then 2110 is great, it works. The challenge with 2110 is that we've all been used to plugging in cables, and now when you can't plug a cable in, you need a good way for two things to talk together. And you want it to talk as quickly as it was before, when you could just plug two cables between two devices and there it was, you had your video. We need that, and so that's a big part of the problem that MMOS is trying to solve. But that's taking time to actually be adopted, and it doesn't solve every single problem, because obviously it's designed to make everything talk together in an open way. But there's going to be always that one device that has that one quirky thing about it that needs to be controlled as well. And particularly with software-defined hardware, that's a real challenge for us. And so we're having to work with not just MMOS and that's the standard, but also with each individual device to make sure that it talks and behaves the way that we expect it to.
And same with you two. I know you're in various levels of completion of network, but as you're putting it together, were you surprised by anything, either how well it worked or a big challenge that you had when you were doing it?
I was surprised at the standard as far as the video essence part. That just worked.
Yeah, there you go.
Yeah, that's good news. That just worked. There was no problems for the most part with that. The challenge, and even in the audio challenge, was the control system. Everybody has their own control system, and even though the routing control systems have been around for 40 or 50 years, there's a workflow that went behind developing those control systems, and you just can't take that control system and put it right on top of an IP system, which is really a best effort system, and it's how it was architected. So the control system we actually don't have as many features as what we had in our SDI router. Now they're coming around, and it's almost to where we have the same amount of workflows that we had on SDI, but and I see the future as it's going to increase, so much more in the IP world, and that was the whole reason we went IP. We had a aging infrastructure, and to rebuild our infrastructure, the philosophy was well, let's start at the bottom. Let's start with the routing infrastructure and build that, and then go out to the edges as equipment, becomes more IP native.
So along, just a follow-up question to that too. When you decide to do this and you started to go with the IP way for it, did you ever stop along the way and go, oh, why did we do this? We should have stayed with SDI, or was it really just no, full speed ahead? I know a lot of people are asking that, because if you're starting with a greenfield, the common sense seems to be just go with all IP right now, 2110. So I'm really looking for you. Do you agree with that statement? Or do you think there's still a place for SDI, again, for greenfield as opposed to?
As I've gone through it, I think there is a place for SDI. SDI just works. It's relatively inexpensive when you compare it to IP. I still couldn't have gone that way because I couldn't have got to scale with SDI.
So it's the scale part of IP.
Right.
Same thing with you, Francois. If you're building this out, any comments about things that you were surprised about, or that you felt just worked and you should have done the IP thing earlier?
So I agree with Mike for HD signals only. So 2110 in HD, vendor A, vendor B, 95% of the time for media transport, it works. 4K, it's a totally different stories. There's first the quad flow versus single flow issues. So a lot of the vendor are...
Oops, lost your mic there.
Are you doing a quad flow over IP when you do 4K? And some of them, when you do that, then you lose -7. So you basically have to choose between 4K or -7, which was a surprise to me. Now that's a little bit better, but it's still 4K. It's not quite there yet, even for the media transport. PTP is critical in analog, and then in SDI, synchronization was important. In IP, it is as important, but it's to define the right architecture, to make it stable, and the maturity of the PTP stack in each end device varies a lot. So initially it was difficult, now it's better and better. And the last one is, when I was a student, one of my teachers as a broadcast engineer told me, if you want to see where video will be in 10 years, look at audio today. That's done, that's gone, it's no longer the case. I will say that the maturity of the IP stack in many audio device is really behind what it is in video device. So a lot of the audio device doesn't support -7, or they have their weird way of doing redundancy. They don't support proper SDP patching. Control is all over the place. So I will say that in terms of maturity in the broadcast industry, the video manufacturer are doing a better job than the audio manufacturer, and I was expecting the opposite.
Yeah, I was too. I mean, the audio started first, right?
Way before.
Yeah. So it's interesting. So along those lines, were any of you three involved with the decision to just, you knew you were building a new facility, but were any of you involved in the decision to actually say, let's go for it, let's go for all IP? And if so, what did you have to do to convince your organization that this was a safe way to go? Because we just said this before, SDI is 20 years now, plus it just works, right? So this is kind of a weird thing. You know, if you think of the word IP by itself in broadcasting, it's almost an oxymoron, because one is a completely reliable network, very well-known characteristics of performance, and the other one, if you look at it, is in general statement, again, without looking at it how we're using it, IP is like anarchy, the complete opposite of it. Of course, that's not how we use IP. We're doing professional media over IP, so we've put those quality of service things in on the stack. But I'm just curious, were any of you involved in that decision, and what did you do with the, I'm curious to hear stories about the manager going, wait a minute, what are we doing? So any order.
Yeah, I will take this one because I have a funny story, but maybe you will not let me exit that area after. So when we started to look at IP, there were still multiple proposals in the industry. Sony had their NMI initiative, Evertz Aspen, then VSF had TRO3, it was not even 2110 at the time. And we wanted to see what was possible. And we wanted to see how TRO3 was viable in terms of a standard. So we decided to do an open source implementation of TRO3 that became 2110. It is on our GitHub of CBC, and it's now part of the official main branch of FFmpeg. So it's only the receiver, it's not the sender, but it's there, it works, you can try it. And we did that with only one objective, and it was to be able to show up at one of the interrupt to see under the hood how mature was it. And as an end user, you're not allowed to do that, but as an implementer of 2110, we were allowed to do it. So that gave us a lot of data that I was able to use internally to show management that it's real, there's real momentum behind it, there's real manufacturers that are trying to make it work. And yeah, now you don't have to do that. It's done, 2110 is there. But when we did that initial pitch internally, we had to find data that didn't exist at the time. So that's how we managed to get that.
Go ahead.
This is really my second IP router. The first one I implemented was another Evertz EXE using Aspen for Fox broadcast operations. So,
and that one, just to compare, that one uses the MPEG-2 transport stream.
No, we never did do that.
Oh, you never did.
We went straight to Aspen with that.
Oh, you did? Okay.
We launched it with Aspen, and it worked very well for what they were doing for broadcast operations. And I went to Fox Sports, and I wanted to, build a new routing infrastructure because I had to rebuild the facility. And I was starting with the router, and to sell it, the president of Fox Sports was very frustrated. He'd go in his control room, and he's on a router that's maxed out, and he wants to see a source and he can't see it. So the way I sold it is, you need scale, and the only way we're going to get scale is to go IP. And it's proven. I put one already in, and now we just will go with the next version with 2110.
Fantastic. And then how about yourself? Were you involved at all in the beginning when they were first rolling out?
I joined the project right at the stage of commissioning the interim hub and the IP truck, so I wasn't involved in that. But for us, I know it's the scale thing. What we wanted to do at the scale, both in geography and in we've got 27,000 flows that we manage in the hub. If you were trying to build a series of routers in remote production to do 27,000, video streams, you just wouldn't. Yeah, it can't happen. So, and we needed to do it quickly too. Like the time, realistically, it's been 12 months of R&D, but within 3 months we got up and running, and you couldn't do that. Commission 4 trucks and 7 control rooms in 3 months in baseband.
Yeah, I mean, that's one of the things I guess we should point out on this. When you're using baseband SDI, it's one source, one destination on a cable. When you move to all IP, you now can have hundreds, maybe even thousands of these types of connections on a single physical wire. That's where the scaling can come from along the switches. It's just a much tighter thing. Plus, IP is inherently, over Ethernet, is inherently bidirectional versus unidirectional. Makes a good thing on that. So, with that on mind, now that you've had a little bit of experience on this, and you guys maybe have a couple of maybe dents in your armor, so to speak, where rocks didn't quite land where you wanted them to. Can you name a few things that people should consider before undertaking a new project of this scope when you're going to all IP? Just a couple of things, lessons learned that you might want to share.
I would say really understand your workflows. When you lay out your routing and figure out what you really need. And when you're going into an IP routing world where you'll have multiple streams on a fiber, now you have to worry about your bandwidth utilization, because if you have 6 SDI streams on one 10 gig fiber, if you don't max that out, because it's both transmit and receive across that fiber pair, if you don't max it out, you're now going to lose, you'll never recover that bandwidth that's internal into that router. So you want to really look at maximizing your internal router bandwidth when you lay out your router. And if it means having to take some of those 10 gigs and bring them out to an aggregate switch, so that your main routing core can be maximized. I think that's really important that it's laid out well.
Anybody want to add to that? Things you want to share lessons learned, so to speak?
Yes, two of them. First of all, just to select the equipment, the vendor, the partners, took way more time than in SDI. Because you need to test and test and test. And just to write the tender, there's so many. In SDI, you said you need IO in the product that complies to SMT, blah, 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 and that's it. And you can trust that it's going to work. With IP, there's so many detail, and our tender become very, very too thick. But that was very helpful to see which one of the feature of the protocol were implemented, which one were not. So it took a lot of time to write, took a lot of time to analyze, took a lot of time to test and choose one vendor. The other thing is that SDI, you've said it, it just works. IP, the configuration part takes, there's way more parameter to set up just to get basic functionality to work. And that's an issue for me, because if we want IP to be viable in the long run, we need to be able to automate a lot of the deployment process, a lot of the configuration process, and we need tools to enable that. Many broadcast vendor doesn't provide such a tool, so that's why we've chosen to go with an open source product, very well known, called Ansible, that we use to do the deployment and the provisioning of even not just the software component, but even things like the embryonics gateway, we use Ansible to deploy them. And that's, you need that kind of tool to make that viable.
Anything you want to add?
I think there's lots of practical lessons that you learn. We learn early on to go BiDi on transceivers where possible. It cuts down fiber because there's just a never-ending checklist of fibers that you're running around the place, and it just gets rid of polarity issues, particularly out in the field, because we're all IP from edge to edge. So from right on the sideline of the footy field, right the way back to the TX path where we hand off to Fox Sports. It's 2110 the whole way, and so making life easy for yourself by planning, by using bidirectional optics. Again, vendor choice is really important, and we stick to particular vendors, and that's helped us because once you've got the configuration, you can then take that configuration and stamp it out across your network, which is where you buy back some of the efficiencies that you lose from the upfront time in planning and configuration. And then monitoring is it's a game changer for us. The whole way in which we alarm and monitor our network has completely changed, and what our broadcast engineers need to do and what our network engineers need to do to make sure that we have a solid, stable network and that everything is behaving the way it is requires a lot of our own external monitoring tools. The good news is there's a lot of good open source stuff out there to be able to implement that, and a lot of good open standards to be able to interrogate, to get telemetry, but all that telemetry is useless unless you have the alarms and the protocols in place to do it, and we've had to learn a lot of lessons about that.
That's actually an interesting, good point, because obviously if you're doing testing on your own internal network, when it's one signal or one connection per wire, you can isolate it down pretty easily. Sometimes I think this is it, they just disconnect the wire. Sort of can't really do that with fiber. So maybe we should take a few moments on that. What is the stage of monitoring for IP level and being able to isolate down to find actually where the problem exists versus comparing that to how you did it with SDI?
So it all comes down to the OSI model. So you start at the physical layer, you make sure that all of your deployments are following some basic health checks. So cleaning fibers before you plug them in at the sideline or at the OB truck. Then you're looking at your layer 2 connections, making sure all those are stable. So interface monitoring, looking for flapping interfaces on switches. Your layer 3 stuff, so your BGP for us, making sure that the connections between the networks are all stable, all the way up to deep packet inspection for making sure that your the flow that you're subscribing to is what you think it is. So if you think you're subscribing to a 1080i flow, do an inspection on that and make sure that the resolution is 1080i. There's a whole bunch of steps in between there, of course, but it comes down to taking the OSI model, and using that as your framework for your monitoring.
Anything further from you two gentlemen regarding how monitoring has changed and your ability to be able to do isolation? What's different?
Well, I'm glad we don't have to do that because I don't have the staff to be able to, with the expertise to go into that kind of level of monitoring. They don't have that kind of networking experience. So the routing system that we put in, it's really abstracted. All that, they put their SDN layer on top of it, so you can look at the different points, and they're giving those monitoring status. So you're not having to go in and look at it, through a regular traditional network switch. I don't have the staff to do that, but it's still not easy. The vendor, Evertz, has gotten a lot better about putting the different monitor points in and some of the tools to monitor the flows from end to end, so when you do have a problem, you can see where the issues are. So in that sense, it's getting better, but it's also, still training the staff just to understand this is really IP and how to troubleshoot. It's not a patch cord anymore going into a waveform monitor. Instead of running to the equipment room, you run to your computer and open up the monitoring tool and see where the signal's going bad.
Yeah, big different view, right? It's a big change in philosophy, yeah.
Yeah, and we don't have the staff to do that kind of level of deep inspection either. We rely on tools to do that. So you need to look at it from an engineering point of view, from a setup point of view, designing and architecting the network. But then we rely on tools to do it. We rely on automation. We don't have humans plugging into switches looking at stuff. That we couldn't possibly have enough humans to monitor that many flows. Yeah. So we do rely on tool sets, but you've got to make sure those tool sets, there's a lot of tool sets out there that monitor parts of the story. What we found is we've had to integrate multiple tool sets that deliver that whole story from physical right the way up to the application layer.
Francois, anything to add?
Yes, we talked a lot about operational monitoring, but there's something new that we had to do, which was engineering troubleshooting. Because you receive a piece of equipment, comes with a new firmware, you want to test it before you put it into production, make sure that the 2110 stream is legal and it works fine. And because we had a lot of early equipment from our partner, and that's part of the deal. So we were an early adopter. So they agreed to send us equipment with beta firmware. And knowing that it is beta, a lot of time that there is bug. But the good news is that there's a lot of tools available, a lot of open source tools like the EBU list live IP toolkit that we use a lot to do troubleshooting, that we also contributed to add feature that was missing. There's the sector for Wireshark that Thomas Edward did that we use a lot for troubleshooting. And that all part of engineering troubleshooting. I hope it's because we were early adopter and that moving forward that will not be necessary anymore. But at this day, it's a necessity.
So scalability, excuse me, was something that all of you mentioned was one of the reasons you went to all IP. But let's talk about something that's slightly different now. Is there a killer app? Something that absolutely, if you weren't all IP, you couldn't do it?
For me, it is to have a software-defined infrastructure. And software-defined doesn't mean, so when you look at an equipment, you need IOs and some kind of processing. Whether it's audio, video, it always comes down to that. With SDI connector or AES connector, the device can only do what you can enter or take outside of the device. So it's way less flexible. In IP, you get rid of the connector definition, and it's all data into packets. And it comes down to how much processing you have. It could be software. It could be FPGA based. We have in our system a lot of software-defined FPGA cards. In our case, we're using the C100 from Lavo. that the same card can do multiple things according to what we need. We also have software-based product like the ITX playout solution. So it runs on Dell server that we procured ourselves, and that could be defined to do something else in the future. So for me to have a software-defined infrastructure, it's only possible if you move first to IP, and then you can go to software-defined.
Okay, so it's really the flexibility and agility of being able to repurpose a particular piece of a device or however different functions.
Yeah,
okay.
be it FPGA-based or CPU-based, it doesn't care.
Anybody else for a killer app?
Well, I think kind of expanding on that, I mean, we don't really have any killer app per se, other than, I talked about earlier, is the multi-viewer. You know, multi-viewers, you never have enough, but if you have a pool of multi-viewers, since it is in this flexible environment, you can send them anywhere. And you know, we do remote productions also across the country, and we can send route multi-viewer feeds to another area easily, and or to an event, as a return feed for an event, and they want to see feeds from our facility, and that has probably been our killer app.
Okay, anything?
Yeah, I think for us it's about the pooling of resources, and not just multi-viewers, but it's the dynamic pooling of all of our resources. So, sort of a data center model where we have one, in our Sydney hub and our Melbourne hub, they're connected together. They can share each other's resources. We can, on one production, dynamically assign an EVS to that production, and then tomorrow it could be used in a different control room, or even in an hour's time it could be used in a different control room. That all relies on being able to quickly configure it, and as much software-defined hardware as you've got, and as much flexibility as you can get from having IP, from having good control systems over the top of it. Really, that's where we get huge benefit on being all IP.
All right, so to summarize this, when you're moving away from a hardware-centric set of devices where it's at a physical facility, and everything moves to software where you can share these resources. This is the ultimate goal, of course, of the Joint Task Force on Network Media, was to go from where we are today to what is referred to as the dematerialized facility, where it's a facility, you're running the same functions, but you don't even necessarily know where the computes are in your network. It could be anywhere, it could be spread across multiple locations. Absolutely. And that really does add a lot of flexibility. Of course, with that flexibility also becomes some concerns that everything is done. Now, we've been very fortunate that we've had massive all-IP interops that have been sponsored. You can see them by the members of the JTMM here and in Ames as well, doing these interops to test these things. Is there anything else that needs to be tested beyond that you think we should do further interops on that maybe have been left out, or things you think would be good to have, when you get we have 50 to 70 different vendors now that have done interops to show their equipment interoperability. Anybody?
Audio is still a challenge in IP, and coming up with some standard, audio formats and how different systems handle different groups of audio. I think that's a problem right now in the IP world.
So testing that would show maybe pick some preferred channel assignments or something, or how things are done, just to kind of
whether maybe even treat it as objects. I think a future standard is going to address this, but maybe treating the audio like stereo as an object, as 5.1 as an object, which is more of a how people work. That's how broadcast, works in the workflows. Is, we don't really, when you think about it, care about the individual channels. We care about the group of channels. So let's just route them as that, group of channels.
Anybody else want to add?
I think just because it's still a maturing environment, we just need more of what's been happening, and it's just going to take time. Every month we're hearing about new 2110 devices out in the market, and it's just going to take time for those interops to keep happening, and for everyone to get established and comfortable with that. And MMOS will help because it provides an easier way to integrate that. So as people implement ISO 4 and ISO 5. I think both of those two things will help.
Uh, the very first interrupt were done using, it was only to test the transport layer, mostly with static parameters, so no SDP exchange, everybody agrees on a format. And that was okay, it was the first baby step to get there. Then dynamic SDP was added after that, then ISO 4 for registration and discovery. After Christmas, ISO 5 was added also for connection management. And that gets us almost where SDI was. I said almost because it's not there yet, but almost. But to make IP sustainable for the long run, there's a lot of stuff that's missing. Like ISO 7 for control, ISO 8 for audio channel mapping. Then for me, the configuration is it's an issue. So to have the industry to provide me with tools to simplify configuration, that's necessary. Then comes security. I'm so happy that hackers don't know how easy it is to hack broadcast. So now I said it publicly, it might change, but and it's I'm tired to hear the answer from manufacturer, just insulate your network. By definition, a network is not insulated for me. So that's not a valid answer. So that needs to be looked at. That's why I encourage all of you to go on the EBU website, try to find a beautiful pyramid, and ask the vendor to provide everything it takes to make IP sustainable for the long run.
So when we look at this, obviously this is a sort of the merging of two worlds. It's the information technology infrastructure and knowledge of networking, and of course the broadcast engineering world, which is the 24 by 7 by 365, very different model for that. So moving forward to this, what was easier for you, taking broadcast engineers and teaching them about IT networking, or taking IT networking engineers and teaching them about broadcasting? Anything there?
My first introduction into that dilemma was when we did the 2110 implementation into FFmpeg. Broadcast engineer didn't have the knowledge to write the code. So we reached to DevOps, and the hardest thing for us to explain them was the why are we running at 5994 even in 2018, and they got it in like 15 minutes, and then they came back 3 weeks after and they had an almost working implementation. So it was easy, but at the same time, I have broadcast engineer, sometimes young, sometimes more experienced, and they want to learn about IP. So it's really a case-by-case basis, but you cannot turn a broadcast technician into a network engineer overnight. That doesn't happen, and the opposite is also true. So you need to put those guys together, or girls, and make them believe they have, and it's not believe, that's the truth, they have a common goal, and they have to work hand in hand to get there, and without that, it's impossible.
Mm-hmm. Anything else to add?
I think that's pretty good. The roles are, I think the roles will merge eventually, but it's not going to happen overnight. It's going to take a long time. And for us, we're redefining the tiers of engineering within each of those disciplines to sort of make that work. I think there's going to be an Uber engineer that can do everything, and a small handful of those, and then they're going to be monitoring, and they'll look after the 24/7. They'll look after the escalation point. Things like the ITIL framework, which is an information technology help desk kind of support mechanism that IT companies have used for years and really successfully. They will bring in that kind of model of like a level 3 system administrator / engineer who can do everything, down to level 1 engineers who are more help desky automation, and specialist level 2 engineers who do specialized jobs. I think that's the way we see it going at the moment.
So along that way, training was already a significant issue in the broadcast engineering world globally. Has migrating to all IP helped or hindered in that? Is it easier to train? How was your training for your operations changed?
the timing is still an issue. I mean, we're live video flows. It's always going to be an issue. I mean, we want to deliver frames of video at exactly the same time. We have to. We have to be able to switch between them. That's the way it works. And I don't think we're ever going to get away from that. And there has been challenges in the IP world, especially early on. And it wasn't so much the transport, but it was the control system being able to keep up with what needed to do on switching that. But once they got the control system tuned in to the essence flows, it's been pretty solid. And with the timing and PTP, it's really haven't had any issues with it.
That's really good, because I know the PTP was a big challenge for a lot of people to begin with. PTP, again, being the precision time protocol, switching from the traditional station's black burst setup to something that is based around a numbered clock that's on an internet protocol is a big change and a big difference when you're trying to, again, remind everybody here that we're not talking about standard internet traffic here. We're talking about real-time video where a difference of a frame or out of order frame thing, it can't happen, and it all has to be the same reliability on that. So how has your organization changed at all by the impact of going to all IP?
For us, it's night and day on how they work, because it was always a limitation around the routing infrastructure. 3 or 4 or 5 routers. The whole facility had 19 routers, and we're trying to integrate with all of them, and you're having to double up sources on so many of the routers, and you're like, okay, where do I get this feed? Which router am I controlling? Having one routing system with the multi-viewers integrated into it, it's like a problem that just went away overnight.
Wow. Cool. That sounds one of the biggest advantages of going all IP then, right?
Yep.
Anybody else have anything else to add?
Yeah, we'll take a different angle. Before, I will say 3 years ago, CBC had engineer for the French services, broadcast engineer for the English services, and IT network engineers for everything that was corporate. And those 3 teams talk to each other, but as less as possible, to be honest. So it would have been totally impossible to do the migration to IP in that structure. So the whole organization was restructured. So it's not just that we've taken those people and they report to the same boss. All the merger were done within the team themselves. So now my broadcast engineer are in the exact same team as my network engineer. So they both work together, they sit together in the same room, and that helps a lot. And it is the same for operation also. So that.
So one team for both now.
Yeah, exactly.
You're the same?
Yeah, from our point of view, it's changed from production all the way back to engineering. I think that was one of the things that surprised us, was the amount of training that we'd have to do in the production team, the operators, to actually get used to the way things work in IP. From the fact that clean switching is not like it was on a baseband router, all the way through to fiber and network connections, and then on the engineering side, I think we've embraced it as an opportunity really to bring up a new generation of engineers in hiring trainees really fresh out of university, and putting them through training programs to get them to where we need. But also then it's been great to see I think a lot of the established engineers then being able to teach their skill set to a network guy, and the network guys teach their skill set to an established guy. So there's actually been a lot of collaboration in the project that's been great to see. And I think, that can be looked at as a challenge, because there's knowledge gaps on both sides, or it can be looked at as an opportunity to actually bring teams together.
Right. So we've talked pretty much about uncompressed flows. Any complications or any needs you might have for lightly compressed video to help out anyway? Is it a benefit or a bane to go with lightly compressed flows as well? Anybody?
I haven't addressed it. We don't really have a need for it at this time. I mean, our compressed flows are usually the compressed flows that are going, outside the facility over the WAN, where it's a different type of, way to control it. It's not really part of the production environment. I think it will be in the long term, especially once we start moving to the cloud, and 2110 moves to the cloud, and then it's going to be, at that time, then we're going to have to address on how that's all going to work.
Okay, any other comments?
We're obviously having to use compression in some of our more regional and remote areas. But for us, that's fairly transparent because of.
Is it a high bit rate, lightly compressed version, like a JPEG 2000 or something similar?
It's a VC2 based open
VC2,
compression.
okay.
So yeah, direct. So
Direct Pro, yeah.
And again, this is one of the benefits of having a software-defined platform like the C100s. Where you can just rock up to an event that is remote and switch it into a compression mode, and then roll back to the next venue and switch it back into uncompressed. For us, it doesn't really make a big difference. It's handled.
Yeah, and when you get to the other end, you just uncompress it.
Just uncompress it and spit it out again, and off you go. So yeah, again, that's a good example of where the software-defined platform works great for us, because we, traditionally, you would have two devices doing those two roles.
Can you? Go ahead.
Yeah, I would like to add a little bit. There's place for both in the marketplace.
Yeah.
And I see a lot of people that are very vocal about that, and 2110 is DOA and it's useless, or the opposite, that uncompressed is the only way to go and we don't need compression at all. But the things are, each workflow is different. We do some stuff in the cloud where compression is very useful. And we do some other application where latency must be kept to bare minimum. And latency adds up quite fast in some application. So for those, and it happens that those are on-prem application. So then uncompressed makes sense. We have a wide area network in Canada that connects our 88 sites together. That's all done using JPEG 2000 compression hardware from Evertz, and it works fine. So there's, it depends on the application. There's not a one size fits all.
So can you quantify any of your workflow improvements? As you know, you have steady production workflows, how you get things from capture to adding graphics on it, to maybe doing transcoding in different formats and things like that as it's progressing through your workflows. Can you quantify any major difference or improvements you got by going to all IP? For
me, probably the best example of that is in our recent, so we've recently gone to 4K in some of our control rooms, and I was surprised at actually how easy it was to migrate that within our existing infrastructure. Really, it was a matter of catering for the bandwidth. So there was some, moving from 10 gig to 25 gig on some of the edge devices, and scaling up a little bit. So adding some more blades, so we got some more processing, and that was about it. So
that's pretty impressive then, because that's a big change going from HD to 4K. So
I mean, we moved our 2 trucks and 2 control rooms to 4K in maybe 4 weeks.
Wow.
Which, again, you just don't do that in the base.
With SDI, that would be a big, long transition time. Anybody else have anything to add with their workflow changes, or?
I think that the pooling of device that was already mentioned earlier is a big workflow change for us, because in our current facility, we pool some of the equipment, but that means to physically move them, because some equipment like camera control unit are installed in a specific rack for a specific studio, and to pool them means to move them. Where in IP, everything is accessible everywhere, because you can make the router bigger than you can ever do in SDI.
Very true.
And that enables a lot of new workflows that didn't exist before.
Yeah.
Before, we also had a separate ecosystem for news and general TV production. Again, for size reason or scale reason, now we can all combine that together. So yes, that affects the workflow a lot in a very positive way.
Good. Okay, with that, I want to please thank my panelists here. I hope you found this discussion interesting, and we know that all IP is here to go.
All right.
Thank you very much for attending. Thank you.